We are going to move on to our last talk of today, which is our long talk from Roxanne Beltran and Allison Payne, who are going to be talking about some novel acoustic recorders that can listen in on the ocean soundscape.
Awesome. Thank you so much. Well, we can't see you, but I'm going to assume you're still there unless you tell us otherwise. We are super excited to share a research project that we've been working on interspecific eavesdropping in the deep sea. So my name is Roxanne Beltran. I'm an assistant professor at the University of California, Santa Cruz.
I'm Allison Payne. I'm Roxanne's graduate student.
And yeah, we work on large marine vertebrates and marine ecology. We're kind of biologists by training, but more and more we're realizing that as we think about how animals move in the landscape and what they're actually doing, we really need to understand what they're experiencing and what they're perceiving. And so we've sort of both moved more recently into the acoustic space to try to get a better sense for what exactly the animals are doing. So we're really, really excited to talk to you about some of the work that we've been working on. So the deep ocean is characterized by darkness, by cold, and by crushing pressure. And for the animals with the physiology and morphology to sort of access that mesopelagic zone, it's also a treasure trove of prey, like these lanternfishes that you can see here. So the marine mammals that we study, including elephant seals, make a living by finding these deep prey resources. They travel hundreds of miles offshore and thousands of meters beneath the ocean surface to eat these fish and also squid, and they spend most of their lives in the darkness of that twilight zone. But if seals are traveling hundreds of miles just to feed in the dark, one of the major questions that we have is how are they actually finding the prey? So we know from research by colleagues that at a really fine scale, they use their whiskers. The video that you're seeing here is actually a very small video camera glued to the cheek of a seal. So you're seeing the seal's whiskers sort of move through the water at hundreds of meters below the ocean surface as the seal tries to find fish, the wakes of the fish that are swimming in front of the seal. So we know they use whiskers at a really fine scale, and they also clearly use some kind of memory to return to the areas that they've been before. We also know that they have really good hearing, as good as toothed whales into the high frequency range. But like the other marine mammals that use this mesopelagic zone, so about 200 to 1,000 meters beneath the ocean surface, the seals can't echolocate. So if echolocation is a sensory adaptation that allows toothed whales and dolphins to more easily find prey in the vast open ocean by basically emitting high frequency clicks and then listening for the return echoes to figure out the distance and size and shape of objects, including their prey. We wondered, is it possible that elephant seals might be finding their prey by basically eavesdropping on the echolocation sounds made by odontocetes in the open ocean? Basically, are they stealing information about where the prey are by leveraging a sensory system that they don't actually have? And it turns out that eavesdropping is actually really common in wild animals, both within and across species. So, for example, dik-dik listen for the alarm calls of the go-away bird and basically increase their vigilance when they hear that bird. And eavesdropping can also be really useful for foraging contexts. So sika deer are basically drawn toward the call of snow monkeys because the monkeys eat fruit and the deer can easily forage on that fruit that drops to the ground. But to our knowledge, we don't know if eavesdropping occurs or facilitates foraging success in the deep sea. One tool, of course, that can give us clues about what's going on in terms of acoustic interactions in the open ocean is passive acoustic monitoring, where microphones can measure all sorts of things we've already heard about today, including sound produced by animals, sound produced by the earth, like earthquakes and rain and wind, and also sound produced by humans, like seismic surveys and shipping and development. And these acoustic monitors can be used across ecosystems, so across habitats on land and at sea and in aquatic environments, but they do pose some trade-offs, of course, in terms of how they're actually used. So in terms of their temporal spatial resolutions and in terms of sort of the coarseness of those data. So for example, fixed acoustic monitors can record for really long periods of time. but only in a single place. Whereas acoustic monitors that are on moving platforms like sail drones or ships can record across locations, but usually only for limited durations of time. And so that sort of brings us to our study system. We know that instruments that are small and can be attached to animals can help us not only understand what individuals are doing, but also understand their environments. And these instruments attached to birds and reptiles and mammals and all sorts of things are being used at scales that we've never seen before. So right now, tens of thousands of animals across the globe are instrumented with these biologgers. We can watch them move and we can see what they're doing and we can understand their habitats. And so we basically wanted to leverage this ability to make instruments, to carefully attach them to animals to collect data about the environment, this time using acoustic. So I'm going to pass it to Allison, who's going to talk about the project.
Yeah, so if our goal was to figure out if seals are eavesdropping on whales, then we wanted to kind of make some hypotheses about what that would actually look like in our biologging data. So we had 3 data streams on the elephant seal, and so we made 3 different hypotheses about kind of what each would look like if the seals are following those whales. So at the broadest scale using GPS, we would expect over a 12 or 24-hour scale that when a seal heard echolocation, she would switch maybe from transit to searching behavior, for example. At a more hourly scale, we can use the depth recorder to look at the shape of the dive, and that can tell us the behavior that the seal is doing, whether it's transiting or foraging or sleeping or some other things. So in this case, we would expect that if she hears echolocation, she should switch to foraging behavior, and we would see that in the dive record. And then finally, at the smallest scale, we can use the recordings themselves. And this is where that kind of amplitude and proximity gets in. We can use that fact to look at the received level of sound on the hydrophone. So if seals are going towards whales or if they're coming closer to each other, then we should see an increase in the received level of sound on that hydrophone. So that's what we're kind of looking for across all of these different scales. And elephant seals are a really excellent system to look for this evidence of eavesdropping because they have this extremely impressive 10,000 kilometer round trip, foraging all the way into the open ocean, and then they come straight back to the beach in California, about 20 minutes up the road from our lab, where we can find and handle them. So we have extensive practices and protocols in place to sedate the seals, instrument them. Then they go off on their foraging trip, come straight back to the same beach usually, and then we can remove the instruments and do the whole process again. And so this allows us to reliably recover the data. And because the seals are quite large, around 500 kilograms, the instruments don't usually, they don't have big impacts on the seals or affect their natural behavior. And in fact, a lot of instruments are first tested on elephant seals because they're very robust animals. And we have a variety of sensors that we can use. I mentioned the GPS tag that can measure latitude and longitude, but also the depth trigger, which can tell us how deep they dive and the shape of those dives. And like I said, that can tell us if they're transiting, resting, or foraging. And the last piece is our passive acoustic recorder, which can record the soundscape of the deep ocean on foraging trips, including high frequency sounds like echolocation. So from that tag engineering perspective, the thing that was really missing was, as I think Tim mentioned earlier, having battery to last for this really long foraging trip, and something that could also survive the pressure and salt water of the open ocean. So this was a real engineering challenge. So thanks to the Arnold and Mabel Beckman Foundation, we set out on this adventure to build this tag. We partnered with engineers and acoustic experts at Cornell who helped us through a lot of iterations of housing shapes, different battery potting techniques, different configurations of everything to try to avoid air bubbles that could implode under the ocean's extreme pressures. And so it was many, many, many prototypes. I mostly broke things, and that was a very instructive experience, I think. And there were also, all kinds of other challenges, supply shortages during COVID-19. But our first prototype we were able to put out in 2023 on a juvenile seal. We did this kind of translocation of her. So we picked her up from the beach. She was a young seal. We can't do this with the adult seals, but we picked her up from the beach north of Monterey Bay, drove her on Highway 1 down to Monterey, and then set her out in the evening. And over the course of a couple days, she swam back to Año Nuevo. And on this trip, the recorder worked. It was able to record sound, including the sound of a boat that caused the seal, as she was heading, she was doing for a moment, and then swam back deep into the ocean for safety. So it's kind of the same response we see to predators that she saw to a boat. After several more prototyping refinements and lots more pressure testing, earlier this year, we were finally able to deploy an instrument on an adult female. Her number's H391, and she got it in about 2 months. So we programmed the acoustic recorder, which is just an audio moth, potted in a housing with batteries that are potted in epoxy, lithium batteries, and a 1 terabyte memory card. So we thought we had a pressure trigger so that we hoped that the instrument would record for the entire trip. Ultimately, the amount of data that we get is about 700 hours at this sampling rate, so about 30 days. In a very exciting kind of month, she came back to the beach where we were able to head out to Año Nuevo Island, recover her instruments, and download the acoustic data. And she had done a really good job finding food. She had gained even more body mass than is typical for this foraging trip. So she came back very, very fat and did a really good job. I'm very proud of her. And so over the course of her 56-day trip, she swam about 800 miles from her natal beach in California all the way up to Oregon. Most of her dives were around 500 meters, but she did dive down to a maximum depth of about 1,000 meters. And the tag did not crumble under pressure, which is a relief. She hung out offshore of Oregon for most of the trip, several weeks, before heading back to our research site. So most of our recordings were while she was kind of up in Oregon off of Coos Bay up there. And the data that we received contained over 2,000 dives. We have confirmed hearing killer whales, Rizzo's dolphins, Pacific white-sided dolphins, sperm whales. There's also lots of other kinds of noise, ship noise, flow noise, electrical noise, all kinds of other things in there. But there's at least some species that are pretty easy to identify. I don't know if you all can hear this, but any guesses as to who this might be? Not sure. So this is, I'm not sure if we can hear from that full clip, but this is a recording of killer whales and Pacific white-sided dolphins. So really what you hear is the Pacific white-sided dolphins going, they're pretty high frequency, but when the killer whale whistling starts to show up, the dolphins completely stop vocalizing. And at the same time, that seal did that kind of anti-predator behavior and dove back down to the surface. So now we can kind of start to get into our hypotheses and look for evidence of eavesdroppings at each of these different scales. So I'll just show you really preliminary results. We haven't done much analysis on this. We're really in the process of doing that. But just the very teaser cutting edge for all of you. So at the scale of the GPS, most of the odontocetes were detected near her foraging location in Oregon. So we looked at her step length, the distance that she traveled over the course of 12 hours, and the more echolocation she heard, the shorter distance she traveled. This is some evidence that the seals are associated with the presence of whales. And, one question we get a lot is couldn't they just be both attracted to the same location instead of being attracted to each other? Which is a really great point, and one reason why we're looking at this at so many different scales. So, oh, thank you. So it's important to look at all of these different scales, and I wanted to know whether the seals are changing their vertical behavior immediately after hearing a whale or dolphin. And so here again, we found some evidence that the seal's diving behavior tended to switch to foraging dives when the seal heard echolocation, which suggests that the seals could be hearing odontocetes and then capturing prey and using that information to take advantage of a foraging opportunity by diving to where the prey are located. So the two yellow boxes here highlight times when the animals that are underneath it were present. So in the first one, there was a long bout of Pacific white-sided dolphins, which if you are a whale and dolphin person, you might say, they don't dive very deep. They don't eat, they don't eat mesopelagic fish, but I recently found out that they do. About 60% of their diet is deep water fish, and they can dive to 1,000 meters. So I found that really interesting. And then in the second bout, there was hours and hours of sperm whale detections. And sperm whales and elephant seals don't eat the same prey, but elephant seals and giant squid do eat the same prey. So there's another reason why they should all be gathering in the same location. And then finally, at the finest temporal scale, the strongest evidence for eavesdropping would be that amplitude or volume of whale calls getting louder through time, especially if we can find that in concert with transiting dives as the seals move towards the feeding whales. And so since we're in an acoustic session, you've already seen lots of these today, but just to orient you a little bit, the format of the spectrograms that you'll see is time on the x-axis and frequency on the y-axis, and we can identify different whale species based on the different frequencies at which they call. And the color will be the amplitude or the volume, so the bolder and brighter colors are louder sounds. And this is what we've seen with our seal. So for both dolphins, which are at these higher frequencies, and the sperm whales at the kind of lower frequencies, both of those vocalizations become louder through time. And again, they are happening at the same time that the seal is foraging. So we're really excited about this because it could be the first evidence of eavesdropping between species in the open ocean. And that might be a really cool strategy that not just seals, but other animals in the ocean might use to make their living in this place that's, really quite dark, quite patchy, might be really difficult to find food otherwise.
Cool. So thanks, Allison. Yeah, as you can see, we're really excited about it. We have a lot of work to do. Allison's about to finish up her PhD, so she's going to be hustling to sort of use a bunch of analytical approaches to figure out exactly what the strength of evidence for this eavesdropping is in a really quantitative and rigorous way. We're also planning to deploy 10 more instruments next year and also produce a professional science communication video so that people can see what it's like to be a seal swimming hundreds of meters below the ocean surface. We're really excited to show that these echolocation signals may be important signposts in what we consider to be a relatively featureless open ocean. And as human impacts like increasing ship noise and whaling may impact deep sea communities, we can use these tools to understand how things are changing to be able to better conserve these habitats for the species that call them home. We can also combine this tag with other technologies we're already using, like CTD fluorometer tags to learn more about the oceanography, accelerometers to learn more about exactly how much fish the seals are eating, etc. And all of these things can provide really useful integrated monitoring approaches for understanding ocean ecosystems and figuring out how to conserve them and regulate human disturbance like the shipping traffic that is increasing more and more every day. So hopefully we showed you today that we can harness these naturally migrating animals to collect really useful ecosystem information about man-made sound, and that there's a lot of future possibilities that we'd be really excited to talk about how we might expand this tool and this application to other species. This is, of course, becoming more and more important. So we want to thank everybody, particularly the engineers who kept putting things back together after we broke them, and to the whole acoustics community who's really taken us in and taught us more about this tool so that we could use it. And the last thing I'll say is just we've partnered with a bracelet company to sell bracelets that are associated with tracking data from each of our seals, including H391. So you can actually get her tracking data in the palm of your hand. It's a nice little gift and things like that. So feel free to go to follow.com to buy a bracelet. And with that, we will thank you guys for your time, and we're happy to take any questions.
Oh my gosh. That is, first of all, it's so cool. And also, every photo of a seal with a little tag on its head makes me smile and laugh. Because they look so silly. You're getting lots of applause emojis. And there looked like one question came in a few minutes ago. Where did it go? From Chris, asking how much of the recorder is custom built PCBs and electronics versus how much of it is off the shelf hardware.
Yeah, the recorder itself is just an audio moth, and then there's a 3D printed housing, and some various battery configurations that we have tried. So the most custom part is the housing, but yeah, the acoustic recorder itself is just your regular old $100 audio moth.
Perfect. Love to hear it. And there's, I think, a similar-ish related question from Tom saying that he might have missed it, but what makes this acoustic tag different to something like the D tag from the early 2000s that also has a GPS attached and a longer battery life?
Yeah, D tags are awesome, and we hope to put out some soon. But up until recently, they weren't recording at those high frequencies that are needed to detect echolocation. So most of the acoustic tags that have been put out up until now have recorded the sound of like fin whales, which are making really low frequency sounds, and then a lot of work on weather, wind and rain, and other low frequency stuff. But to our knowledge, this is the first time that we're getting those really high frequency recordings of the open ocean. So that's the biggest difference.
Got it. That is so cool, and I definitely want to be tracking all of them. It's so fun to congratulate her on coming back and being well fed. I love that. So we just hit the hour mark. So we will start wrapping things up. But if you have any other questions for any of our speakers today, feel free to drop them in the chat, or send them to the community email address, and we'll try to get those answers to you. I want to give another thank you to all of our speakers today for their lovely and informative and engaging presentations. It's been a joy to talk about all things acoustics with everybody for the last hour. I'm going to end the recording now, but you're all invited to stick around for our after hours session where we stop the recording and have a more casual conversation about the talks, and anything else that is on your mind, conservation tech related or otherwise. So thank you so much again for coming, and we will see you next month on August 27th.